Hey, what's up everybody? It's Spencer and welcome to my shop. If you've just stopped by the channel for the first time, I appreciate you taking the time to check it out. And for my subscribers and everything, people that have been following along, I appreciate that a lot. Shout out to Skip for these sweet hats that he made me. I really appreciate it, man. They're cool. They fit good. That's basically all you can ask for out of a hat. And he even made me a couple because I tend to screw them up pretty quick. So thanks, buddy. Today we're going to be taking a look at my Z50R again. I've been working on this thing pretty relentlessly since I started this series. We're working on the rear end now, and that's a pretty crucial part of all this. After I get this done, I should have a rolling chassis, and I'm pretty excited about that. I've got the swing arm mounted right there in a fixture that I made over the weekend. So I'll show you guys how all that works, and we're going to make us a swing arm today. So let's get started on it and see how it goes. This is my swing arm fixture that I made for myself. It's pretty simple setup. I'll take it apart and show you guys how it all works. In theory, I've never built a swing arm before. I've never built a fixture for a swing arm before, so this is all trial and error for me. I'm just as curious to see if it works out as you guys are. So for the rear, I took shoulder bolts and turned 28 thousandths off of the shoulder diameter so that it would fit into the axle slots. I don't remember what that converts to in metric, but 0.472 if I remember correctly, to where it's a tight fit and it will hold both of the axle stays in line with each other so that the slots are dead up even. For the front, I used a little bit of a different method for them. I turned some aluminum inserts that act like the swing arm pivot bushings, and they line up and hold the front mounts in line with each other as well. I've already machined the two front swing arm pivot mounts. I still have to cut this swing arm apart, but I got to check some clearances on some stuff first. And then I've ordered some 1-inch chromoly square tubing to build the rest of the swing arm out of. My game plan here is to go for extending the swing arm by 1 inch. When I did the math, and if anybody wants to know, I basically spent a bunch of time trying to find shocks that would fit the build for what I wanted to do. I wanted to increase rear wheel travel by a pretty decent amount without making the Z50 extremely long. When I see a bunch of people's full mod bikes with like the 3-inch extended swing arms and then like 330 millimeter shocks on there, I don't really like that too much. This is just a play bike for me. I wanted good suspension, but not at the sacrifice of having like a huge bike like the size of a 110. It's still a 50 at the end of the day. I want to treat it that way. I just wanted some decent suspension. I'm getting older. I'm not super old, but I'm getting older, and I appreciate some good suspension a lot more than I used to when I was a kid. So the reason that I built the fixture this way was simply for the fact that I could build it around the stock swing arm as far as the spacing is concerned, and then I have it slotted to where I can adjust the length. So I built this fixture, on my CNC plasma table, and then I did a lot of it by hand. And then I squared everything up for the stock fixture. For the stock swing arm, and then made a mark of where stock length was, and then also a mark of where plus 1 inch would be. And so, as I was building it and everything, the swing arm was mounted. I marked it, and then now I can cut the swing arm apart and extend it by 1 inch. I hope that all makes sense. If it doesn't, please let me know. But now we'll cut apart the stock swing arm and, start building. Now that I have my axle stays cut off, I just lopped the tubing off with my angle grinder. I'm gonna mount it in my little pan of ice right there where I can kind of twist the thing all around and make it a little bit easier on myself to cut out. And then I'll have to kind of fit it up for square tubing. I might have to do a little bit of mill work, but shouldn't be a big deal. So I've got the tube removed out of one side. I just kind of roughly cut it out. I'll do the other side now and size them both up to fit the 1-inch square tubing. So I did want to show you guys how I'm actually notching this slot right here to fit my 1-inch square tubing. I've already done this side, and basically all that I did was I used my shoulder bolts because I knew they fit in there very tightly. And then I took a scale, which is a straight edge, and I sat them up against there, and I made a line right there and right there. So I put the straight edge on the other side, made another scribed line right there. And then I measured those two lines and marked the center in a couple places. Then what I did was from the center line, I marked a 1/2 inch up and also a 1/2 inch down. And then I just took my angle grinder after I had made a straight line all the way a 1/2 inch up and a 1/2 inch down from my axle slot, and I cut it, and then I just check it with a 1, 2, 3 block, and as you can see it fits in there. And I'll just take my Dremel tool with a tungsten carbide burr, or whatever you like to call it, a rasp or whatever, and I'll clean this up. I'll make myself a straight edge, and I'll make both of them even, but that's basically all that I'm doing with this. Now that I have both axle stays notched out, I can start worrying about the tubing. I've got to figure out the angle that I'm gonna cut the tubing to, and then I will notch it out on my mill with a hole saw, and then I'll cut an angle at the back of the tube right up against here, just so it looks nice, doesn't look all boxy and junky. You may be asking why I'm using chromoly steel instead of mild steel tubing for this project. The main reason is that chromoly, size for size, is twice as strong as mild steel. So what that means is that if I was running 1-inch square tubing like I am for this project with mild steel, I would need to run 1/8 wall thickness to achieve the same strength as using the chromoly steel that I opted for with a 1/16 wall thickness. So you can basically cut the weight in half, but also maintain the same amount of strength. Basically all that I'm doing here is clamping on the tube in a vise, which I indicated, and then I offset it because this is a 1-inch tube and I'm using a 1 1/8 diameter hole saw. I offset it by that 1/16 of an inch to get it in the center, and then I'm setting it at close to a 6-degree angle. You can see it's 5.9 right there. That's close enough for what we're doing. So basically I'll just bring the hole saw over to the edge and take a cut until I get a radius in there. It doesn't have to be, completely half the diameter of the tool. I don't want it to wrap all the way around for welding purposes. I'd rather just have to weld a little bit, not all the way around the diameter of the tube that it mates up with. After a little bit of trimming on both of the axle stays, I managed to get both of the swing arm sides fitted up. Got a nice tight fit on there. I went ahead and cut some 45-degree angles on here, which I'll make some plates to weld on there. And then I've got to make my cross support, and I'm gonna just tack everything together and then pull it off the fixture and just check my fitment. I cut the tubes at a 45-degree angle and made some quick end caps out of some scrap steel that I had laying around, just so they would look nice when I weld it on there. It'll be a nice smooth transition into the axle stays. Now that I have both tubes attached, the only thing left to do is add my center support right here. So I'll have to figure out the angle between these two, which I already know I kicked them at 6 degrees. So I should just be able to take a tube and cut a 6-degree angle on both sides of it opposing, and it should fit in there once I figure out exactly where I want it placed. I'm gonna kind of use this for reference, knowing that at a minimum I can come back 1 inch further than this, but I do want to keep it close to the frame if at all possible, to give me some room to run a bigger tire down the road if I want to. One little trick I wanted to show you guys. I drilled this tiny little hole in this left tube right here. Reason being is this is my cross support right here. When I slide it over and into place, it'll be hidden, but when I'm welding this center tube, it'll keep my weld from blowing out from the tube getting pressurized from the heat. The heat will make the air expand, and if you don't give it some way to relieve, then it's going to blow out. Now, water will condense inside of tubes as well, so it's not a bad idea to have some drain holes in there. I'll be putting drain holes at the bottom of these tubes, you know, pretty close to where I welded this plate on both sides. I'll have a small hole there too as well to keep it from rusting out in the future. Now that I have the swing arm completely tacked together in a bunch of different places so it won't move around, I wanted to take a second to explain how I'm going to go about doing this and why. When I weld this thing completely together, I'm going to be pretty careful about a couple of things. I want to be careful about my travel speed and also my heat input. One thing about Chromoly steel is that it is a low carbon steel, so meaning that it does get harder with heat. A higher carbon steel would get even harder than this. The thing about Chromoly is when you look at like a KTM stock frame, you can tell that it was MIG welded together. It goes through a heat treat cycle after that because MIG welding puts a lot of heat into the joint all at one time. With TIG welding, I can manipulate that a little bit closer and keep the heat affected zone a lot cooler than MIG welding. When it comes to Chromoly, one thing that you want to take into consideration is you want to have about an amp to an amp and a half per thousandths of wall thickness is a good place to start. You never really want to see gray in your weld. If you do, that means you got it a little too hot in that area, and you definitely don't want to do that consistently all the way across the joint because it could make it really brittle. So I'm going to be moving pretty fast. I'm the kind of person, my style of welding, I like to crank the amperage way up on the machine. Like I'll have it at about 120 for this. I'm not using 120 amps. I'll use nowhere close to that. I just don't like to press on the pedal super hard. So I'll be cruising at, you know, probably 80 amps or so. Not a whole lot there, but that's basically it. When it comes to Chromoly, you definitely want to be quick about it. I'm going to be jumping around a lot to keep the heat to a minimum in my joints, give them time to cool in between. So I won't be like welding one piece completely solid at once. I'll do a joint here, then I'll do a joint here, you know, here, jump all around, you know, just keep zigzagging around until it's all done. Now, I think that turned out pretty good, all things considered. I haven't been doing a whole lot of welding recently, and so I could definitely use some work on consistency's sake, but I think for the job that it's doing, it turned out pretty cool. I'll put it on the bike now, and I've already checked the fitment and everything before, but I'm gonna actually mount everything up like 100% solid and see how it all turns out. Pretty happy with the fitment. Everything seemed to go on the way that it should. I've got some more parts coming, but I think up next, I'm gonna put the forks on and get them shortened to the height that I want. And I'll probably do a video on that as well, on how to shorten these standard forks in a pretty easy way. I guess that's about it for today's video. I appreciate everybody stopping by and hanging out with me while I built this swing arm. Like I said, it's not something I've ever done before, so I hope you guys learned something. I definitely did. This has been an experience, but I enjoyed it. I think it turned out pretty cool. Hope you stop by for another video. Next time I'll be shortening my front forks, I believe would be the next step. And we'll keep rolling from there. After I do that, we should have a rolling chassis, and then it's just checking off all the boxes from there. Thanks for stopping by.